take a quick look at this before I do example 2, and it just kind of tells you that sometimes things look more complicated than they are, and you can really simplify them by recognizing that they have the pattern of a quadratic equation. And the pattern of a quadratic equation is where you might see something, and it might be an expression, you know, not just an x. But if you could just break it down, um, you know, represented by one letter, you would see that you'd have a quadratic equation. Okay, so it says p can be any expression, okay, as long as it is squared in one of the terms, and it's there by itself, right? Not squared, I guess, in the other term. Okay, so an example would be right here. Okay, sorry, I did not mean to cross out that 3, but here's an example, right? Because you have it looks quite complicated, but if you were to represent this x plus 2, because it's squared in the first term and then it's just there in the second part, that you would see that if you substituted just a value of, or a letter like r in for it, you can see that you definitely have a quadratic equation. Okay, so what they say is when you're faced with something like this, you can just use something that we would actually call a dummy variable. So you can just say let r equal x plus 2, and then you would substitute that in. It would become 3r squared minus 13r plus 12. Okay, so then using the techniques that we've talked about for factoring, I won't show you just because we'll do some of these, but 3r minus 4 times r minus 3. Okay, and then you know that in order to find your roots, well, I guess we're not going to find our roots, we're just going to rewrite it. You know that you don't want to give an answer with r's in, because that's not what you were added, so, or that's not what you were asked. So you're going to go 3, and then you're going to substitute that x plus 2 back in for r. Okay, just makes the factoring part easy. Okay, so then x plus 2 minus 3 is the other factor. Okay, so 3x plus 6 minus 4. Okay, and x minus 1. 3x plus 2 and x minus 1. Okay, so it just makes it so that something that seems like it might be complicated is actually not really complicated at all, because you can use that dummy variable. Okay, same thing here. Even though this looks like it's so complicated, it's not. It's just a difference of squares. Okay, so you would take that 3x plus 1, okay, take the square root of the first, which is 3x plus 1, okay, minus the square root of the second, okay, and then square root of the first plus the square root of the second. And I put them in brackets there because you want to make sure that you are not changing. A lot of people, I think, want to change the sign on this one. Okay, don't. Okay, the only thing you're changing is whether you are subtracting or adding those, okay, between the two factors. Some people, when they do one factor where they keep the sign the same, right, when they're doing adding, and then when they subtract, they think that that's the one they have to change. But you don't, okay? So, and then you simplify. You have to distribute this negative sign, obviously, on both, and then you simplify, and it becomes something nice like this, okay? So, example 2 shows us that. Okay, so factoring polynomials of quadratic form, you can see here that x plus 2 is squared in that first part, and it's not squared. It's to the power of 1 in that second part. Okay, so what I'm going to do is let r equal x plus 2. And that just allows me to write it as 12r squared plus 24r plus 9. Okay, I will take out a factor here of 3. Okay, I always want to simplify things as much as I can by taking out any common factor. That allows me to deal with some smaller numbers, which I like to do. Okay, I'm going to find two numbers that are going to multiply together to give me the product of 4 and 3. Okay, so they have to multiply together to give me 12, and they have to add together to give me an 8. Okay, so I can go through all my factors of 12. I know they're both going to be positive because they have the same sign, because they multiply to give a positive number, and since they add to give a positive number as well, they must both be positive. Okay, so 1 and 12 don't add up to 8. 2 and 6, they do. Okay, so that's how I would do it if I was doing it a little more quickly. So when I replace that middle term, 8, put the 6r and 2r. Okay, so I'm going to keep this 3 here. Okay, and I'll put square brackets now because I'm going to take my greatest common factor out of my first two terms, and that'll be a 2r. Okay, And when I take the greatest common factor, well, there isn't one, so I write a 1. Okay? Always want to write a 1 there because that's what I need to have something left when I take that factor of 2r plus 3 out. Okay? If you've done this properly, these will always be the same. Okay? So 3, and then when you take that 2r plus 3 out of there, you are left with 2r plus 1. Okay? Now I'm not done because my original question had an x in, not an r. So I have to substitute that back in. So that's 2 times x plus 2 plus 3. Okay? 2 times x plus 2 plus 1. Okay? Maybe you would rather see square brackets here, right? A little less confusing. Okay, too many brackets, right? That'll be a square one, and that'll be a square one. Okay, and then to get it back, we're going to go 2x plus 4, right? That gets distributed, plus 3. And then this one becomes 2x plus 4 plus 1. Okay, so to write it, our final answer here is going to be 3 times 2x plus 7 times 2x plus 5. Okay? And so that's the factored form. So it's really not as complicated as you might think. Okay. The next one, B. Wow, this looks really complicated, doesn't it? There's so much going on in this one. Okay, right? Looks very complicated. We've got S's, we've got T's, oh my goodness, okay. But not complicated, right? Because what we have here is a perfect square, right? The coefficient's a perfect square and the thing in brackets is a perfect square, okay? And we have another perfect square and they're being subtracted, so it's just a difference of squares. And the key thing that you need to know how to do here is to recognize that pattern, okay? So the square root of that first term is going to be 3 times 2t plus 1, right? Because instead of being squared, it's just itself. That makes the square root, okay? Plus 2 times s minus 2, okay? And the other factor will be multiplied 3 times 2t plus 1 minus 2 times s minus 2. Okay, and I always put them in brackets because I don't want to be losing any signs here, right? Okay, and then in the next step, I'm going to distribute, okay, 3 times 2t plus 3, okay, plus 2s minus 4, okay? And I'm really careful in the next one especially because I'm going to have a negative sign. So this is going to be 6t plus 3, okay, minus 2s, and again, plus 4 because I'm going to have negative 2 times negative 2, okay? Simplify a little bit. There's not a whole lot you can simplify here. And so just the 3 and the negative 4 are going to add together to give you negative 1. And over here, the 3 and the 4 are going to add together. Okay, so 6t plus 2s minus 1, 6t minus 2s plus 7. Those are the two factors. Okay, so a little bit of substitution, a little bit of algebra involved, but not a difficult thing to factor if you recognize right away that it's a difference of squares.